On the 18th of September 2024, we welcome back Jonathan Aylen from the University of Manchester and also the Newcomen Society. And he told us the remarkable story of how RAF planes that were flown in the Battle of Britain were built using German machinery, and therefore how German technology helped Britain win World War II. Here's Jonathan to tell us this remarkable and little-known story.
What I want you to do today is to sit back and suspend your disbelief. I'm going to tell you a remarkable story. It's also a very chilling story. It is the case that history and historians often forget or omit embarrassing things. They don't want to tell stories that somehow run counter to the popular narrative. I'm going to tell you an embarrassing story about how the RAF of the Battle of Britain essentially were relying upon German technology to get their very aircraft produced and in the air. But I'm also going to tell you a shocking story about how the Nazis mistreated one of their best leading engineers because he happened to be a Czech Jew. How he fled to Britain and brought with him all the leading technology of the time, the cutting edge technology of the time, lock, stock and barrel, and allowed Britain to rearm by building the machinery that was needed for rearmament to German designs here in Britain. He played a crucial but hitherto unrecognised role in our victory in the Second World War. So at one and the same time, this is an object lesson about history, why you should question history, but also a very shocking moral story. You may question its popular relevance, but for those of you who know the story of semiconductors, you may ask how it is that Taiwan semiconductors managed to achieve their current prominence if they hadn't passed over their current leader for promotion in America. Perhaps the whole story of global semiconductors would have indeed been very different. Let me show you a very familiar picture. This is what you all know as a Spitfire. It's an iconic aircraft, stress skin construction, Merlin engine. This is a Mark I Spitfire, and it's flying out of Duxford, which is now a museum, in 1938 when this photograph was taken. Notice, apart from the flat cockpit, which geeks will have already spotted, it has a two-bladed wooden propeller. Why a wooden propeller? Well, because we hadn't imported the machinery to make the metal ones yet from Germany. Okay, so hold that thought and you'll begin to realise some of the absurdities in this story. I also want to tell you about an unrecognised hero, that's to say a Czech Jew called Ludwig Lervy, seen here with the First Lord of the Admiralty, so in excellent company, just 20 months after leaving Germany. So that's Ludwig. Very unusual photograph this. He's wearing a hat. He never wore a hat. He's also had his hair cut, so he must have thought it was a serious, prestigious event. And he's wearing a black coat, which is, as far as I'm aware, the only smart coat he had. And the gentleman in the background behind his right shoulder is Lord Stanhope, who was the First Lord of the Admiralty, very soon to be replaced, of course, by Winston Churchill. This photograph, as we'll see, was taken in December 1938 at the opening of the Heavy Tube Department at Chesterfield for the Admiralty. Okay, as I said, historians like to overlook embarrassing facts, particularly if they don't fit the national narrative. The first fact that I find astonishing when I actually dug into the statistics is that aircraft production in Britain during the 1930s up till about 1942 rose 100-fold. So just think about that in terms of producing. One year you're producing 1 million cars, the next year you're producing, a decade later you're producing 100 million cars. This is the kind of expansion that you don't normally see. The second point that I'm going to stress in the next couple of slides is the fact that there was radical technical change in aircraft design, from wooden biplanes to monoplanes made of aluminium and magnesium alloys. That much is very familiar. You've seen the picture of the Spitfire. That's a monoplane made of aluminium alloy stress skin construction. The third and the fourth points, however, are probably completely new to you. That the rearmament program to make those planes relied almost exclusively on specialized machinery from Germany. And not only did we import the machinery from Germany, we imported the know-how to make it. The technical and trade journals of the 1930s, from 1935 onwards, when the Luftwaffe was declared as being in existence, were packed with articles on German materials, German designs, and German manufacturing practice, and that continued even after the war had broken out. Okay? So even after the war had broken out, we were publishing articles on enemy production practice, many of them supplied by Germans before the war. Okay. Having said that the RAF of the Battle of Britain was built on German machinery and know-how, I might usefully add that this wasn't necessarily a one-way flow. Aircraft geeks amongst you will know that both the Stuka and the ME-109 were prototyped using Rolls-Royce engines. Okay? The expansion of aircraft production was carefully planned and quite extraordinarily backed by government effort. This was extremely complicated because even in 1934, they knew that the planes they were building in the early 1930s would be obsolete by the time the expansion program had rolled forward. So this Hawker Audax, one of perhaps 750 or so built, was completed in about 1932 and was obsolete and out of service 5 years later in 1937. So it was not just a training aircraft for these personnel at an RAF technical centre. It was also a training aircraft for the aircraft manufacturers to get them up and working with jigs, although noticed it's not stress skin construction. But this was the team that was to go on and build the Hawker Hurricane, which was not stress skin, only stress skin wings. It was tubular body. So this is Buckinghamshire Hawker Audax, by about 1937, resigned to a training role, and I suspect their Vickers Wellesley bombers in the background there, equally obsolete. So they had this problem that they needed to expand the aircraft industry, but the designs weren't yet there. Similar problem too for aero engines. And if you want to see two photos that capture the rate of technical progress in aircraft design, let me show you these two. When the Luftwaffe came on a social visit to the RAF in 1938, they were shown the Handley Page Hayford Mark III as the latest frontline aircraft for the RAF. This, as you can see, is basically built as a branch of the furniture industry. It is wooden, canvas, wire, fixed undercarriage, underpowered engines, biplane. Technically, totally hopeless, I would think, in the environment of the Second World War. That was the frontline aircraft for 1938. Consider the picture below, which is of an aircraft built just 4 years later, which is a Lancaster with all-powerful Merlin engines, stress skin construction where the aluminium alloy skin is taking a lot of the load and resisting the torsion and so on, with large elements in there made of, as we'll explain later on, extruded aluminium, particularly that large long Bombay spars. A complete sea change within 4 years, which is very evident to your own eyes. A complete sea change in design, a complete sea change in construction, a complete sea change in materials, a complete sea change in the whole, the engine power, the whole approach to aircraft production. Now this caused a problem. They needed to foster a complete new industry in order to supply the aluminium, or the aluminium alloys. Aluminium's of course a very soft material, pretty useless unless it's alloyed. They needed to develop a complete new industry in order to supply the needs, first of all, of fighter command in 1939-40, and then subsequently bomber command with the construction of the Stirlings, Halifaxes, and above all Lancasters for the bombing campaign to take the war to Germany. This is just one example of many shadow factories that were built both for engines and for aluminium. You'll see some more, but this is a spectacular aerial view of high-duty alloys, more of them in a minute, at Distington in Cumbria, or it was Cumberland, not far from Workington, a complete new factory built in less than a year, turf cut in January 1940, completed and beginning to operate by December 1940. The tool room was a local garage in the local village of Distington. Complete new plant built almost exclusively to make aluminium alloys components for bomber command by the million a month. And some of you will have heard your grandparents talk about scrap drives. So, for example, after the fall of Dunkirk, housewives in Britain were exhorted to bring in their aluminium saucepans and kettles because they were required for the war effort. Actually, they proved to be a very good source of material because they were relatively high purity and easily alloyed to requirements. The only people who complained were not the housewives, but the scrap dealers who'd been carefully hoarding up aluminium scrap and found that some of their scrap was unsuitable and they weren't making the money that they'd anticipated. So a complete new industry emerged, but during the 1930s, expanding at breakneck speed during the 1930s and throughout the war. Now, here's where the surprise comes. We were learning all this from Germany. And it's not surprising that we were learning from Germany because they were the technical pioneers in this aspect of aircraft construction and aircraft design. This is, of course, a Stuka, which was obsolete by the time the war broke out, although it proved very scary and effective flying with proxy as a proxy air force in the Spanish Civil War. It is stress skin construction, although it's somewhat underpowered, certainly underarmed, and the fixed undercarriage would not have helped its performance. It was relatively slow. And why was Germany emerging as the world's biggest aluminium producer by 1938? If you had a moment's thought, you'd say, well, no, it can't be. It must have been America. No. It must have been Canada. No. No. German chemists did contribute a great deal at the early part of the century. And I'll come back to that when we talk about duralumin. But the reason for that expansion was exclusively to arm the Luftwaffe. So the German aluminium industry went 1930, before Hitler, about 75,000 tonnes a year, doubled by 1938 just to make aircraft. It made a quarter of the world's aluminium production. And believe it or not, I came across an item in the archives at Kew discussing whether they would buy aluminium sheet from Germany to complete the Bristol Blenheim bomber in 1939. Okay? That's called trading with the enemy, isn't it? The war hadn't broken out, but there was a suggestion that there should be lots of opportune purchases of German material because, of course, they were a great source of supply. So we have German technical leadership, German production leadership in making aluminium and also magnesium alloys. Magnesium alloys are a footnote to this story. Now, you are right when you speak about German chemists, because they had pioneered the use of a particular aluminium alloy called duralumin. Aluminium is, as I said, is far too soft to be any use, but duralumin was it's an alloy of aluminium, copper, a small amount of magnesium, a tiny amount of manganese, and duralumin has this property that it strengthens, it age hardens, it strengthens if you leave it after manufacture. And it was a German chemist, yes, that found that out. Just as I recall, and I may have got the story wrong, I apologise, before the First World War. It certainly was used in airships during the First World War, so the Zeppelins pioneered the use of aluminium alloys as a structural material. And in particular, it was pursued as a design material by a German designer called Junkers, and he was roundly mocked when he came to Britain. He spoke to the Royal Aeronautical Society in London in about 1926. And the interesting thing about that is if you read the report, all the other papers have the discussion reported at the end, but not Junkers, Hugo Junkers. Why? Because it's widely reported that he was mocked. People played on his name and said, oh, it's just junk. It's just junk. And the Americans and the British were very slow to adopt the idea of all-metal aeroplanes. It didn't do Hugo Junkers any good. He wasn't a fan of Hitler's. He only wanted to produce civil aircraft. He was put under house arrest for not cooperating. His firm was taken from him, and he died under house arrest in 1935. So it wasn't a nice ending for Junkers, but there's no doubt about it that the Germans are amongst the pioneers. So a whole new basic industry was emerging, first in Germany, and of course Britain had to follow, and then at a much later stage, the USA, a new basic industry emerged to supply these aluminium alloys, not just for the skins of the aircraft, but also for the structural members, the wings and the ribs, and also for the engine components. Because if you think about a Merlin engine at 3,000 revs per minute, that means that the piston's going up and down, 6,000 times. You want a really light piston. So one priority was making aluminium pistons for aero engines. But the point was we relied upon the Germans for know-how. And in particular, as you will see, we were especially reliant upon one Düsseldorf-based company called Schlurmann for extrusion presses. More explanation to follow. So we bought wholesale from Germany. We bought forging presses. This is come friendly bomb and fall on Slough country. You'll realise the point of that in a moment. This is high-duty alloys in Slough, a huge press with the name Schlurmann on it, supplied from the Ruhrgebiet, forging propeller blades for Spitfires and Hurricanes, which were then manufactured by Rotol and were available as variable pitch propellers for the Battle of Britain. Nice that we got the forge in time, isn't it? Actually, I'll tell you about a second one that Lervy built, but that's another story. And as I say, the Germans knew exactly where to come. One bomb did actually fall on Slough. It did actually fall on high-duty alloys. This is the Luftwaffe target maps. Luftwaffe target maps are just brilliant if you want information on British industry in the 1930s, because they have a 4 or 5 page folder showing the aerial photo, the ordnance survey map, and a description of the plant. It's just great for historians of technology. You have to translate a bit of German, but you know, I've got a nice lady in York who's been very helpful with that. So there you have it. High-duty alloys on Slough trading estates. They knew where it was. They'd supplied the equipment. Okay, so you don't believe me. Let's have a few more examples until you do believe me. This is one of the other greenfield aluminium plants, Northern Aluminium at Banbury, not too far up. I've been through Banbury on the train today. Northern Aluminium at Banbury, it was in a field of sheep. I've cropped the sheep off this picture, unfortunately. Only employed a very few people when it was set up. 150, I think, in 1931. It imported Canadian pigs, Canadian aluminium pigs, for rolling down into aluminium alloy sheet. And at the time, their market was things like milk floats and milk tankers and things like that. It was to be the biggest producer of aircraft aluminium alloys during the Second World War. The employment went up from about 150 to about 3,500, of whom 30% were women, working 24 shifts. And I've got some wonderful anecdotes at question time about it, if you like. But why do I show you this picture? Well, because the main rolling mill was supplied by, wait for it, a German company. Achenbach Buschhutten in Germany, one of the leading producers of these giant mills. This is a hot mill for rolling aluminium ingots down into base sheet, which could then be cold rolled and annealed and finished. So a key resource for Britain's rearmament programme, although that's not how it was conceived in 1931. It was conceived in 1931 as an outlet for Empire aluminium, colonial aluminium from Canada. Okay. We didn't stop when building greenfield works at just buying 1 or 2 rolling mills, though as you'll see, Northern Aluminium at Banbury built loads of stuff. When we built a greenfield plant, Birmid built a greenfield plant at Quinton outside Birmingham, out in the open countryside, so the aluminium wouldn't be polluted by smoke from the nearby factories. That was completely supplied by the Germans. Almost every single item of plant was supplied by the Germans. This is a extrusion press, more of that later. This is the exit end here, supplied by one of Schlerman's competitors, Umuco, although they also had a Schlerman extrusion press there just as well, because it was invaluable for the war effort. It was completed in 1937. And in case you doubt it was all German equipment, they actually took out an advert in the trade journal Aircraft Production, boasting that their sheet alloy perfection by rigid rolling control was of course being done on a German mill from Achenbach. This is in 1938, September 1938. Okay, so all the equipment there was entirely German. I think I managed to find one furnace that was of German design but British construction, but it's entirely German. Now, this went on. Another key aluminium plant that expanded massively during the late 1930s was British Aluminium Rolling Mills in Warrington, right next to the Transporter Bridge, if you're into these things. British Aluminium Rolling Mills in Warrington. They were a part of British Aluminium and obviously expanded for the war effort. They expanded, incidentally, they set up in 1913 with German machinery. They expanded in the 1920s with some German machinery. And you can read this that came out of the Warrington Guardian, which of course is everybody's favourite reading, a local rag in 1945, which turned up in Warrington archives. Which boasted about how 2 of the strip rolling mills, the widest in Britain, well, they just were completed in the nick of time, ready for the war effort. What they omitted to mention in 1945 was that they'd been supplied from Germany. They'd been supplied by Schmitz of Germany, yet another specialist aluminium machinery builder, and they were supplied just in time for the workers from Schmitz to go home, which was, incidentally, and this is it, still at work in the 1960s, slightly modified. So that's the kind of equipment that we were buying from Germany as war broke out. Not all Germans were equally successful in getting back to Germany after they built their equipment. Northern Aluminium, remember the firm at Banbury, were very expanding at a phenomenal rate and buying both British and German equipment in the late 1930s. But unfortunately, they'd ordered some extrusion presses, 2 extrusion presses from Schlerman in Düsseldorf. Unfortunately, the war broke out before they were just completed, and the poor technicians were interned. Okay, so that's the hazard. If you keep buying German machinery and the war breaks out, well, there you go. Now, you've probably thought of this question. Why did the Germans keep on selling vital equipment to a potential future enemy right up until the outbreak of war? Bit sort of daft, don't you think? But still, there you go. Interesting question. Okay, now, people knew this at the time. History is a case often of digging up what people have forgotten. At the time, everybody knew that this huge amounts of machinery were coming from Germany. The journal Aircraft Production said of the outbreak of war in 1939, the most distressing problem is we won't be able to buy tools and equipment from Germany anymore. You'd have thought there were other issues. You know, if you're going to have an editorial about the outbreak of war, you wouldn't think that failure to buy equipment was the biggest issue. And there's some figures, but basically we were shipping in huge amounts of material from Germany. And that is why, if we move on to the second part of this story, why this man is so important to the war effort. This is a rather flattering painting of Ludwig Loewe, which hangs in a firm in Christchurch in Dorset at the moment. A rather flattering portrait of Ludwig Loewe that was done by a Jewish artist, Westfield, after his death. I don't think it is very flattering. The story of Ludwig Loewe in a nutshell is this. Ludwig Loewe was a Czech engineer. He supplied Britain as head of the firm Schlerman, which he half owned. When Hitler made things somewhat sticky for Jews, particularly Ludwig Loewe, he came to Britain, brought all his drawings, his staff, who were of Jewish persuasion, he brought his staff, his drawings, his know-how, his customer list, and set up Schlerman in exile in London to do exactly what he'd been doing in Germany. So this is the world-leading technologist quitting Germany, coming to Britain and setting up exactly as he had done in Germany, with a vengeance. Because, of course, you wouldn't feel too kindly towards Hitler and the Nazis if you were Jewish. Now, these things don't happen overnight. He had, so to speak, established something of an affinity with Britain in his career at Schlerman. As we'll see in a moment, he had a spectacularly successful career. He was the Bill Gates of aluminium machinery, if you like. He was the guy who pioneered it, developed it, built it up, sold it round the world. One of those pioneering things that he did was the production of stainless steel tubes by extrusion. I'll explain extrusion in a minute, but this is from a beautiful glass negative that turned up of a Schlerman extrusion press making large bottles at Chesterfield Tubes in Chesterfield in Derbyshire. The interesting thing is they're being made of stainless steel. Stainless steel, aluminium alloys, as we'll discover, are quite easy to extrude. Copper is easy to extrude. Lead is where it all started. Stainless steel, damn nigh impossible. Why? Because those of you who are material scientists here will know you have to, it's only subject to plastic deformation, extremely high temperatures, perhaps 1240 degrees C, and at those very high temperatures you're going to wear the dies out, you're going to wear the pistons out, and you're going to have to extrude it extremely fast before it cools down. So this is a Schlerman press that he supplied in his role as head of Schlerman in 1932 to Chesterfield, and this is a much larger but very similar press that he supplied to that high-duty alloy works up in Distington 10 years later in 1942, only of course it now proudly bears his name rather than the Schlerman name, because it's his company, Lurvy Engineering of London, that designed and procured, built and installed and commissioned this plant for the British war effort. Fabulous photo, that's why you use it. Okay, I've been banging on about extrusion presses. Forgive me for 30 seconds for dwelling on extrusion. Aluminium, if you cast it, has a very amorphous structure. It's weak, it just falls apart almost. You've got to transform the crystalline structure of the metal, and that was initially done at places like Warrington and Banbury by rolling, a very traditional process. That's what they do in the steel industry. But a much better way of transforming the metallurgical structure is to shape it under immense pressure by pushing it through a die, as I'll explain in just a moment. You push it through a die, this completely alters the crystalline structure. But what's even better, not only does it come out strong, but it comes out exactly the shape that you want, because you shape the die to make a wing spar, to make a tube, to make whatever component you want, particularly for an aircraft. So my good friend Ian Hoose up in Cumbria did this nice little explanation for me, which is how an extrusion press works. And you can see various elements to it. You can see that it's essentially three massive triangular rods that hold the whole thing together against the opposing forces. There's a hydraulic piston at the bottom here, and a barrel, which we'll see at the moment, moves to take the and takes the hot reheated aluminium for shaping. You can see off on the right there's a stylized hydraulic pumps and accumulators and a reheat furnace. Okay, so what you have to do is as follows. You pull the barrel back and put a die in the head, a bit of glass wool for lubrication, and a nice hot billet. And you can press, for instance, to make a tube, press a mandrel down the centre, and then the piston pushes the rest of the material, and you get an extremely long, perfectly shaped aluminium tube out the far end. I'm just taking tubes for an example because that's what Schlerman did in 1932. The barrel comes back, the tail end that's left in the die is removed, and you're ready for the next one. Just in case you didn't follow all that, a bit bewildered. Whoops. Page up. Come on, play again. There we go. So, billet goes in the container, pierced by a mandrel because you want a tube, pushed through it, extruded through the die, out onto the run-out table at the far end, enormous length of tube. When the billet's finished, withdraw the piston, pull the barrel back, discard the fag end with the die, reuse the die if you're lucky, and repeat. And that way you can just churn out endless numbers of aircraft parts. Okay? Like squeezing toothpaste from a tube, just the same. Right. Ludwig Loewe was the world leader in extrusion plant design. In America, they were all German designed when they eventually got them. In Britain, they were all German and then Ludwig Loewe's. Let me tell you about his career. He was born in what is now Czechoslovakia. He had a Czech name, Ludwig Loewe, and he was one of, I think, perhaps 10 children, one of 9 children. His brother, too, 10 years younger, Erwin, was very gifted and would make a another paper. He arguably was educated at a Technische Hochschule in Vienna. Remember, this is the Habsburg Empire before the First World War, and got various jobs before the First World War, firstly at a rolling mill builder's machine fabric SAC, where he learned how to design rolling mills, which was to make a lot of money for the company in the 1930s, particularly selling to the Soviet Union and France. And then he was persuaded by Paul Maltop, who was Schlerman's son-in-law, to join Edward Schlerman in 1914. And if you read the history blog on this talk, which you'll find on Google, you'll see, of course, they make the obvious point that he spent the First World War building presses, shell presses, to kill British people. So it was a sort of redeeming feature that he spent the Second World War building equipment to kill the Germans. But there you go. He became chief engineer and technical manager, director and joint owner, somewhat controversially, in 1920. So he's a very young man. He's risen at tremendous speed because of his innovative abilities to own half this firm after Edward Schlerman has died. Schlerman, this is their headquarters in Steenberger Strasse in Dusseldorf, which was bombed in the Second World War by the Allies and destroyed and rebuilt after the Second World War. I've been in these offices. It's a very oppressive and Teutonic place. Gives me the creeps. But there you go. That's research for you. Schlerman was a trading company that had moved into hydraulic controls. We won't go into servo mechanisms, but hydraulic controls are quite difficult because you get enormous pressure one side and no pressure the other of the valve. And they had close links with a huge German, long-established combine, the GHH group, but that was good because at the time they could build the equipment that Loewe was designing and selling worldwide, and as I suggested, he had a particularly nice, profitable line in rolling mills. And he almost single-handedly built up Schlerman as an exporting company. 90% of its sales were exports by the troubled 1930s. He went round on sales tours to Japan and the USA. He did very well in copper. There was no aluminium industry in America in the 1930s to speak of, to sell to, so he did very well in copper, and then later got some work from Alcoa as they began expanding, and made shed loads of money selling rolling mills, particularly in, for instance, to the Soviet Union for part of Stalin's industrialization. The path of business, like love, never goes smoothly. Paul Maltop, his partner, who arguably owned 50% of Schlerman, decided to support the nascent and impoverished Nazi party. If you don't know much about Nazi history, they were in the habit of shaking down industrialists for money in the early 1930s because they were skint. All those brown shirts needed paying and they couldn't afford to pay them. I don't know the story of Paul Maltop. He was excluded by court order from Schlerman for embezzling the firm's funds. He led a colourful life. He committed suicide in Berlin in 1933, and I think his life history has yet to be written. That left Ludwig Loewe in sole charge of Schlerman after 1931, but very vulnerable when the Nazis came to power in 1933 because he was Jewish and many of his staff were Jewish. Incidentally, ironies of history number 5. This is a wartime Nazi sales brochure for Schliermann. They were selling to Italy and Austria and places like that. It's a wartime sales brochure from 1942. And because Schliermann was so export intensive, you too can read it in the background. They are selling world to the Axis powers. In the back there, of course, it says Blenhaven on the railway truck. They're using British equipment to advertise their sales success during the Second World War in Nazi Germany. Many ironies like that. Okay, so as I suggested, Ludwig Loewe had a strong affinity with Britain. He sold the plant at Chesterfield. He perhaps had links with Ludwig Mond. I'm not sure about that. We can discuss that later. And so when he was ousted from Schliermann in 1936, his brother had earlier been intimidated by being shot at in 1935 for courting a Catholic girl. So Irwin had fled and gone off and got married in Bournemouth and set up a branch of, set up in France. Ludwig Loewe quit in April 1936 to set up in London. And so he didn't want to fully break his ties. He suggested, for instance, to Schliermann that he could continue cooperating. But when he actually went back for a day, he discovered that the Gestapo were out to arrest him. Fortunately, the Gestapo in Dusseldorf were notoriously inefficient, even by Gestapo standards, so they didn't get the word that he was actually in Dusseldorf. So he came back with 10 Reichsmark and a suitcase after his day trip to Dusseldorf. That was the end of collaboration with Schliermann. So he fled to London and set up a complete new firm just off Kingsway, just near the Aldwych, right at the heart of the British establishment and engineering establishment, and recruited staff from Schliermann, from Germany, for instance, from Jews that had been kicked out of firms like Didier and Mathai Locomotives, and he recruited lots of local agency staff, lots of women. He certainly didn't mind having women designers and draftsmen, and one or two others came through and joined him. For instance, one of his key designers was installing a Schliermann plant in Belgium. He just bought a one-way ticket and kept travelling. Turned up in London with the drawings. Kind of helpful. Because I'm running out of time, I'll skip the poem and tell you something about the contracts. Now, this is a brand new engineering firm. Would you trust them? Within 1 month, they got 2 major orders. One for our friends at Northern Aluminium Banbury, and one from Mond, who was very sympathetic to the Jews, and for copper. So, for instance, the plant at Banbury was going to be used for forging pistons, notably for Merlin engines. This is an almost identical one in trial assembly, upset forging of pistons for Lloyd Cars in Grimsby. Lloyd Cars quickly gave up building cars and became a subcontractor to Rolls-Royce during the Second World War. If anyone can tell me anything about them, I'd be delighted. So the records are almost completely missing on that subject. Okay. He also got a crucial key strategic order backed by the UK Admiralty. Now, wait a minute. Ludwig Loewe is an enemy alien, well, not an enemy alien because he's from Czech Republic rather than Germany, but he was an alien. He had a firm largely run and led by Germans, and yet they get a major strategic order from Chesterfield for a giant tube-making plant to make things like condenser tubes and boiler tubes for Admiralty warships, and to make pressure vessels for the submarine building program. a huge contract which was, for instance, featured in the Times, featured, and this is the page, one of the page feature coverage in the Times, featured on the BBC, featured on Movietone News. It made items like torpedo tubes. You see the torpedo runs in a tube, has to be strong to withstand the pressure. And this is a beautifully posed photo of the components arriving probably from Sheffield at Chesterfield. You can see the bent characteristic spire of the Chesterfield church. Beautifully posed photo with these three little boys in short trousers admiring the huge Pickford truck. This was a huge, beautiful prestige contract to make a two-stage process that pierced a 20-ton ingot, and then by piercing it turned it into a tube which could then be stretched on a draw bench to make a massive steel tube, as I say, for naval purposes. So it was a sensitive contract given to a new engineering firm led by and staffed by aliens. How do you explain that? Well, of course, he was a shrewd guy. He'd done all that pioneering work at Chesterfield in 1932 on extruding stainless. He was well known to them. If you like, he had a prior affinity with Chesterfield tubes. He was comfortable, they were comfortable with him, and it was natural that they should turn to him for this leading German technology for him to design and procure from London. I won't go on about some of his other contracts, but what I will say is about the massive contribution of his firm to the war effort. His obituary said he put even more energy into it after the war broke out. This is a very standard drawing from London in July 1939, a very simple shear for cutting off sheets, which would of course be formed into an aircraft wing or an aircraft aluminium fuselage. He wanted straight edges. And this is a reference list, as they call it in the business, of just how many plants he supplied for the war effort. So at the top we start with about 100 extrusion presses. You can no longer buy them from Germany, of course, once war had broken out. They were absolutely vital to keeping fighter command going and then building up bomber command. Schlerman supplied those presses, along with an enormous number of other familiar things like shell forging presses, cartridge case making machines, and sheet rolling mills for aluminium. You won't be surprised. Because he was so vital to the war effort, within 6 days of war breaking out, the Ministry of Aviation, or aircraft production rather, said would he please move his premises from London to somewhere less vulnerable, because he was such a vital company, and they moved to a large house, Branksome Grange, in Poole in Dorset. And this is the staff in 1941, not quite all of them. We know all their names, but it's not quite all of them there. There's about 8 or 10 missing, lined up for when Hugo Laurent, one of his fellow directors, moved over to America to set up a Lurvy in America, along with his brother Irwin later. He was treated like a celebrity. Remember, he's an enemy, he's an alien from Germany. He was treated like a celebrity. He became an advisor to Lord Beaverbrook. We can talk about that in questions, his rather stormy relationship, but he was mates with Beaverbrook. He saw Beaverbrook every week, all the time. We know Beaverbrook actually went up immensely in my estimation, because Beaverbrook defended Lurvy against Rothschild of MI5 in a hugely entertaining diatribe, which is just worth reading almost for the comedic value. If you want to hear read someone tear a strip off someone who's crucially important, Lord Rothschild as head of MI5, it's absolutely beautiful piece of defence. And he was treated, that the letters to him show the utmost respect. They released his internees, because remember they were German Jews, He was not allowed to visit the United States because he was too valuable to Britain and they were worried he might stay there. He had the unlikely accolade in 1942 of being offered British citizenship. Almost nobody was offered British citizenship during the Second World War under those circumstances. And when he was ill, he was actually offered a transatlantic flight on an RAF ambulance aircraft to go and convalesce in America with his sister and brother at a time when almost nobody flew the Atlantic. Right? And so he was treated as something, as a hero, and unfortunately he died far too young. So what can we conclude with this? Well, the odd thing is, to finish off, many Jewish refugees were not frankly well treated in the UK. Many of them were interned in places like Liverpool and the Isle of Man, or even worse, Rochdale. And they faced very difficult times. They weren't often, their professional qualifications often weren't recognised in many areas. Law, for example, they couldn't practice law because they had a different legal system. Many of them escaped internment by working in the Pioneer Corps in a very menial role. In contrast, Ludwig Lervy was embraced by the political and industrial establishment. He was given a complete free travel pass anywhere in Britain. Remember, he was an alien, and which others didn't get. And he managed to build up this start-up firm, grow it rapidly, and provide incredible high level of employment for many skilled people, as well as arming Britain's war effort. Okay, I won't tell you what happened at Schlerman, but I would like to thank an enormous number of people who have helped me with this research, most notably Lehigh University throughout COVID, who kept a supply of documents coming through to me, which were just magic to appear in my email every couple of weeks, and some very clever people who helped me a great deal. And if you know anything more, please tell me and get in touch. And if you want to learn more, if you just Google Ludwig Lervy, you'll find the second item on that will be a paper that you can download that I've written on this at much greater length. Thank you very much.
Jonathan, thank you very much indeed for that very, very entertaining in many ways, but also very informative presentation. Now, I imagine that a number of people in the audience will have the occasion or possibly the odd question.
I'm just curious, so this might not be relevant, but when in the 1930s with the Schneider Trophy in Supermarine, did they use aluminium for their aircraft? Because you said it was the 30s and it was...
Yes, if you remember, when the designer of the Spitfire won the Schneider Trophy, that was indeed a monoplane, a float plane, of course. As I recall, it didn't have a Merlin engine. It had a predecessor to the Merlin in it, whose name has escaped me for the moment, but I'll remember as soon as I walk out. Kestrel. And you must remember too that that's a very artificial environment, because the planes have got to fly low and level, whereas of course the Spitfire had to fly high and fast. But yes, that was the cutting edge of technology, and that's one of the ways in which we developed experience in stress skin design and construction, yes.
Thank you very much.
Why were Britain and America so dismissive of Junkers?
Do you know what? I only have a second-hand account of that, because the report, the paper in the Royal Aeronautical Society Transactions, as I say, omitted the discussion. But it is said that leading aircraft designers, including some names you would recognise, but I better not slander because I don't have chapter and verse, were dismissive of the idea of metal, which was an obvious solution, because It's an obvious solution because the fundamental principle of aircraft design is light and strong. And duralumin provided exactly what was needed. In practice, there were other aluminium alloys that were used. I don't know, but what I do know is this, that although the design establishment dismissed it, 2 firms went out on a limb and actually got licenses from Durana Metals to produce duralumin in Britain. The first one, as I recall, was Booths of Birmingham, who became a leading aluminium producer in the run-up to the war. And the second one was a late conversion by British Aluminium, who owned the rolling mills at Warrington and a plant at Milton in Staffordshire and so on. And they actually went overboard. If you read the documentation in the British Library, they go from being sceptical to being over-enthusiastic. And duralumin was certainly very, very useful as a engine component as well. Yeah, because it was strong. It had manganese in it, which I think probably helped the strength. Probably a swine to cast. But so I don't know the full story. I would like to know the full story. There is a very good American book on, which is referenced in my paper on aircraft technology, which discusses this whole dismissal of Junkers very well indeed. So I would recommend that, but I can't remember the name of the author. I apologise.
Yes.
I can't quite understand because a lot of the equipment was purchased in the 1930s when we weren't at war, and Britain always thought Britain was best and didn't want anything, and we were spending vast amount of capital buying from overseas when there was no need. So it doesn't add up to me that we were doing it before the war when we didn't need it.
Well, we did, because they had technical leadership. They understood, for instance, extrusion is not a straightforward process. It's a bit of a black art. So you need to know about the temperature that you reheat the material to, how you lubricate the container, wire glass wool is, for instance, one answer. How you then strip the glass off the outside of the the extrusion, how you get for instance, the mandrels right when you're making a tube, how fast you extrude, how fast the temperature will decay in the container, how to make the tubes concentric, how to get the hole right in the middle so that you don't get a wobbly tube. All those kinds of black art things were very hard to develop. And so there were British extrusion press manufacturers. There was one in Gloucester called Something and Platt. Come to me in a minute. No, not Mather and Platt. It was Fielding and Platt. Thank you. Fielding and Platt in Gloucester. And in fact, one of the first things Lurvy did was to recruit 2 of their designers, one of whom was a woman, incidentally. There were British suppliers, but they were very small beer compared with Schlerman or the other 2 German suppliers.
But these were massive sums of money,
yes,
which would require government contracts, and politicians are stupid fellows who don't understand technical problems.
No, believe it or not, the aluminium industry expanded in the 1930s using large amounts of private capital as a bet on rearmament. If peace had broken out in 1938, there would have been a lot of bankrupt aluminium firms. But fortunately for them, their bet paid off, and they made huge profits. They were entrepreneurs speculating on the fact there would be a need for this brand new emergent material. Think semiconductor chips. This is the story of semiconductor chips in the 1930s. Yeah, we now are trying to restrict export of semiconductors to China. It's just the same kind of story. A few people know how to make them. In the case of semiconductor machinery, essentially, you've got to go to someone like ASML in the Netherlands, or you're stuffed. So ASML were the Schlerman of their day, if you like.
Thank you. You're an enthusiast.
Two things. Could it be that the reason why German was looking to export so much, that they were avid for foreign capital, being pretty broke themselves? And secondly, I noticed there were huge stockpiles there of Canadian aluminium. Could it be that we hadn't quite grasped the nettle of huge power production to facilitate the production of aluminium because it eats up electricity?
Okay, I'm sure you're right on the first count and also on the second. On the first count, Germany desperately needed foreign currency. What Germany was in the habit of doing, and there's a superb paper on this in an economic history journal, they used to knock off American designs and flog them cheap. They would steal the intellectual property, build the identical machinery and sell it. Such was the case that by the outbreak of war, they had something like half the world market for machine tools because they wanted the foreign currency. I've done a great deal of work on the transfer of technology to the Soviet Union between the wars. It was the Germans that piled in and supplied large engineering teams to the Soviet Union because, again, they wanted to earn the foreign currency. So they would export almost at any cost. The second point is that we did have hydroelectricity in Britain to make aluminium, to smelt aluminium. One plant was in Scotland owned by British Aluminium, and the other plant was a tiny plant in Wales that, as I recall, actually shut down in the Second World War because it was too expensive. We were very backward in hydroelectric power, apart from the huge contract, the huge plant in Scotland. Fort William, you got it. And also we got bauxite from Northern Ireland, of all places. So, and also, if I may add one further footnote, you mentioned the chemists developing duralumin before the First World War. One of the people that was forced to flee the Nazis was a chap called Sachs, who was chief metallurgist of Dürrener Metal, who got the right to all the rights on duralumin. He went off to America. So that was yet another own goal by the Nazis. In fact, there are lots of very similar stories. Loewe is not a unique story, but their loss of Sachs was a major blow to the German war effort, yeah.
We've touched a bit on export controls. Nowadays, there is a very effective export control system, notably in Britain, notably in Germany, but across the world. And yes, you mentioned the export, but the export of Merlin engines was stopped by Britain on export controls. But I was just wondering, did Germany have any sort of system of the need for a company like Sherman, if I got pronunciation wrong?
That's fine.
To go to the German government and say, can we do this? Because I suspect had that happened now in modern day, it is unlikely, and I won't put it any better than that.
No, I've done my best to read this up, and I know, to be frank, I actually know much more about the export of steel plant during the 1920s and 30s, because that was my background. I have never come across any export controls. So much so that when the war broke out against Britain, the Germans kept advertising and trying to sell their machinery in America after the war had broken out. So just think about that. They were advertising in journals like Iron and Steel Engineer. Schlerman advertised in Iron and Steel Engineer up until the early 1940s, and firms like Damag were also, having ripped off American designs, were advertising, come on, we'll build you a rolling mill cheap, having ripped off your design. I should say, to elaborate, the Germans did not have a reputation for technical quality in areas like machine tools. The only area where they did have technical leadership was in non-ferrous metals, in aluminium alloys and magnesium alloys. That's the only area I can trace. They were damn good at electrics, but then so were the British. So.
I'm not sure whether I missed it during your presentation, and if I did, I apologize in advance. But Lure is supplying that huge list of machinery and huge bits of plant as well to industry in the UK. Where was it made and assembled?
You did miss it because I didn't discuss the exact role of Lurvy Engineering. Lurvy Engineering was like a large process plant contractor of the 60s. They designed the equipment, they sold the designs, they procured the plant, which is coming on to the making issue, for the customer, delivered it, got it delivered to site, and got it assembled and operating with their know-how. So they had to procure from other suppliers. Now, there are two stories here. When Ludwig Lurvy got a major contract at Shotton in North Wales for the slabbing mill, run-out tables and shear for their new hot strip mill complex, he promised to supply, and people from IET will understand this, a large number of squirrel cage motors to drive the roller tables. No one would supply him because the order books were all so long, and there is a huge volume of German correspondence as he writes to all his mates calling in favours without any success. So procurement was an issue. But for those really heavy items, a lot of them seem to have come from Scotland. In particular, and I've been trying to track this down, so if anyone knows, I'd be most grateful. In particular, Beardmore's in Glasgow seem to have been one of the key suppliers of a lot of the heavy machinery. Another one was English Steel in Sheffield, were doing lots of large castings, steel castings for him, and fettling them and finishing them and putting the threads in. So the two that I've discovered as the most prominent are English Steel and Beardmore's, but I'm sure that there are others. The Chesterfield press, the actual press that pushed a hole into these 20-ton red-hot ingots, was subcontracted to Davy in Sheffield, who may then, of course, have subcontracted it to their workshop up in Scotland. I'm not sure about that. Stuart something. Anyway, I'm not sure about that because the archives aren't giving up their secrets like they should. Lots of photos but no captions, you know. So procurement was an issue, but it's fascinating that Lurvy could come to Britain in 1936 and hit the ground running and procure these parts almost straight away for people like Northern Aluminium. So I suspect, and I can't prove this is just hunch, I suspect he'd spent quite a lot of time in Britain from about 1933 onwards. His niece says from autumn 1933 onwards, building up networks and links to add to the ones that he already had from his early sales days in the early 1930s. So a consummate operator.
Talking about how America came into the war in 1941, Alistair Cook of Letters from America fame happened to take a road trip. He just decided to take a road trip round America in a hired car in 1941. I'm sorry, I can't remember the name of the book, but it was a fascinating reflection on the fact that America virtually turned from an agrarian community into an industrial nation during that moment.
Yes.
And he recorded that in the book.
Yes, it's an excellent point. It's an excellent point. If I can elaborate slightly, we've seen that Britain began to rearm, particularly in the aircraft side, from about 32 onwards, and built up this pattern of shadow factories and built up a capacity, for example, for aluminium alloys. What was said here was that Alistair Cook toured America by car in 1941 when America joined the war against Hitler and against Japan, of course, because that's what provokes them, and that the America in 1941 switched almost overnight, I would say, from being an agrarian country to being an industrial country. And that's when places like Ohio and Indiana and Pennsylvania really came to the fore. And I think that's a very acute observation. Because, for example, if we go back to this aluminium production issue, aluminium production, America wasn't really in the business in the 1930s. Alcoa was just beginning to expand in the late 1930s, and in fact gave orders to Schlerman rather than American mill builders. The aluminium industry, as set up by people like Reynolds, exploded in the early 1940s to the point where America went from making less aluminium than Germany, say 100,000, 150,000 tons in 1938, to making something like 600 or 700,000 tons by the time the end of the war came, because of course they too were building up aerial warfare. They too were building up bomber fleets and escort fighters, and they too were building up aircraft carriers. So I think that's a very sharp point, that America almost rearmed faster and harder than the UK. The UK rearmed quickly but gave a great deal of thought and planned it very carefully. I suspect the Americans just went hell for leather, building, for instance, these giant plants to make aircraft and so on. And it's a very telling point about people going from agrarian to industry. I remember seeing a documentary about some leading folk singer, someone like Woody Guthrie, and his grandmother went from being a sort of sharecropper to making Boeing aircraft overnight, and that reflects exactly the point you're making. And that made them actually extremely affluent years during the war, because people went from earning next to nothing in the country to becoming shift workers in factories, earning large amounts of money and having an exposure to a sophisticated way of life. Being able to afford money to spend on gramophone records and hairdos and lipstick and stockings and all the things that, drove life forward in the 1940s.
You mentioned you had some anecdotes to tell.
Where do you want to begin? What do you want to hear anecdotes about? Would you like to hear anecdotes about the staff, about Maltut, about Lurvy? Lurvy's an interesting one. Lurvy's bizarre relationship with Beaverbrook. Okay, Beaverbrook, the all-powerful man who was put in charge of aircraft production and everyone else swept aside. And he wasn't universally admired. There's a wonderful joke, for example, about him ringing up someone like the head of Hawker, and the secretary says he can't come to the phone now. He's unfortunately in the toilet. And he must come to the phone. And the head of Hawker said, no, I can only deal with one shit at a time. So clearly Beaverbrook was hard to handle. And despite his incredibly tough defence of Ludwig Lurvy, he says some very dismissive things. He said, the trouble is he always wants to clear off to Canada. Well, you can't blame him, can you? His mate Kudebeck was there and so on. When one time Lurvy went to see Beaverbrook and said he wanted to go to America to see his brother and also to promote Lurvy presses, which were being exported to America, okay? But we actually had a surplus of extrusion presses by about 1941, and we were wanting to sell them to America. Added to which, to go back to Peter's point, he had the technical know-how, and all their customers over there were screaming to meet him. They used to call him Dr. Lurvy. He wasn't the doctor, but he called him Dr. Lurvy because he was held in such high esteem. So Beaverbrook asked him to hand over his Czech passport, put it in a drawer, locked the drawer and said, "You're not going." And that may be just an anecdote, but it is borne out by the archives at Kew, which quite clearly say secret telegrams backwards and forwards between Britain and Washington, London and Washington, clearly show that the Americans' war effort wanted Lurvy over there, and these telegrams, encrypted telegrams, say no way is Ludwig Lurvy leaving Britain, because they were worried he wouldn't come back, or, He was such an asset. But I think he was a very strange man. You wouldn't want to go to the pub with him. He was a total workaholic. There's a lovely story that I uncovered 2 weeks ago. He had this friend, Dr. Engels, and his wife, and they would take him to concerts, in wartime concerts in Bournemouth. And he'd then go back to the office at 10 at night to sign documents and read plans. And when he was almost on his deathbed, he went to Harrogate to try and recover because he had stomach cancer. And he hoped that a cure would come along. He was convinced that there was going to be a cure, but there wasn't. He was working on his deathbed with all these drawings around him and all these Ministry of Defence officials coming in, developing plans, and he was giving them promises about delivery times and prices and everything. So he was quite clearly a driven man, quite clearly a workaholic, as being very gifted as well. I mean, I've lost track of the number of patents he's got, because it's extremely difficult to trace his patents, because for a start he changes his name. Secondly, if you remember in the 1920s, the Saar and the Ruhr were occupied by the French, so these patents are coming out as Czech patents to avoid the problem of the French occupation, even though he's based in Dusseldorf. And then there are other patents which don't have any name on, they're just Schlerman patents, but clearly his designs. So he was that unique sort of person who is both workaholic and genius, an engineering skilled genius. But as I say, you wouldn't want to go down the pub with him. I mean, he must have been really hard work. Really hard work. He inspired tremendous loyalty. There's some wonderful cartoons of him, which are less than flattering, including one I found showing him as a tortoise. I don't know why. It was always said he was too busy to get his hair cut. He looked like Beethoven. He had long flowing hair. In Germany, when he was in charge of the company, he had long hair. Right? You were talking about 1930s, a leading businessman with long hair. He said he was too busy to get his hair cut. And he probably was. And he sold all over the world. As I said, he went on a sales tour of Japan in the 1930s, a bit tough that. Around the Soviet Union in the 1930s, managed to get a major contract in Siberia where all the rolling mills were Schlerman except for one, which was Daymag. They wanted the currency. Daymag, state-sponsored Nazi organisation. So, you know, you wouldn't want to go down the pub with him, is my conclusion. Having got to know him better, of course his niece thinks he was wonderful, but she actually spent little time with him as far as I can see. Maybe he was wonderful. She was very sweet to him. She used to sing Happy Birthday onto gramophone records and send it to him from America, from New York. Very gifted concert pianist. Yeah.
I think at that,
Colin.
we probably want to draw the proceedings to a close. I think Jonathan's presentation tonight gives us just the beginnings of an idea of the depth and even the breadth of his knowledge and the research into the subject, and indeed into the whole issue of materials technology. So could you join with me in giving him a very warm thank you for his presentation?
Thank you. And if anyone has any insights or any more information or knows anybody, I spend my life interviewing 90-year-olds who used to make aluminium. Please don't hesitate to contact me. That would be great. Thank you.